Hey everybody, so a little bit different style video. I'm actually at my little working area, my desk, versus being out in the garage tonight. That's because I'm excited to show you a new design I have for, it's going to be a vacuum table, so that I can hold materials on my mill without clamps and everything. Instead it'll just be with a vacuum pump in this table. So here in 360, I've already got it open, and you can kind of see I've got two pieces. I'm going to go ahead and hide body 2, that's the top plate. And just kind of to walk you through it, these bolts run through the bottom of it, just like that on both sides. They're measured to maximize the size of the table for the mini mill, the Sieg X2, that's the one I have. And then I just got some bolts that will fit the same threading as the T-slots for the table. So you basically just put the T-nuts in the slots, run these bolts down, and this sucker's clamped down. This is 1/2 inch thick aluminum. It's 4.2 inches wide, so from here to here. The reason it's 4.2 is I went out and I measured my Y-axis travel with the CNC Fusion kit, and right now I can safely run 3.7 inches. 3.7 plus a 1/4 inch buffer gives you, on each side, 1/4 inch gets you 4.2 inches total. So that's how I got the width. The overall length was just a function of the current table size. So the idea is just to not sacrifice any of the table travel by using this, but also it's sized exactly what it needs to be so that you're not running the back of this into the column. So it's basically sized for the mini mill, is what I'm trying to get at. So yeah, you clamp this sucker down with these two bolts into the T-slots. You've got a little threaded hole here. It's pretty small. I think it's a 16th inch pipe thread. So that's just a little nipple that goes in there, or a pipe, or a little brass, like a bung, hose barb, I guess. And so this would go to your vacuum pump. Vacuum pump, you click that on, it would suck the air out of this cavity here. And then that is why we have this other body, so this plate that just screws down on all 4 corners. And then you can drill holes in here. Basically, this could be a sacrificial plate, or you could make it more of a universal plate. I've seen some that they look kind of like a waffle, where they've just got slots everywhere, just broken down into squares. And then they run like a gasket material wherever they're going to be using the vacuum. Because obviously you can't maintain vacuum if you've got a hole that's just open to the atmosphere. All the vacuum is going to be relieved. So my main thought right now is just to make a blank plate and then run a program that puts holes and slots in all the different places where parts are going to be, so that you can make this one plate that fits. It's basically your jig for a part. So like these emblems, for example, they're pretty small. I could actually fit 4 of these on here within the cutting area. And then I could write a program that cuts a slot around the lettering so that this thing sucks down exactly in those spots. If I were to use a universal one and it was sucking in between the letters, the second that it cuts that, the air would the vacuum would escape that way. So that's kind of the idea there. I'm hoping it works out. I think it will. I mean, it's pretty simple physics. You know, you're just sucking, so shouldn't be too bad. But so yeah, that's the project. I figured I'd show you this because it is difficult sometimes to get a video out in the shop every week, because for every one of those projects out there, there's typically a couple nights in here playing on CAD. You got to order materials, you got to get all this stuff together before you can ever actually go out there and say, yeah, tonight we're making this. And so I figured I'd kind of give you a little background. Besides, it is cold out there. It's been in like the 20s all week, and I don't really want to be out there. and this is what I've been working on, so I figured why try to throw together a video for you when on something that I haven't really spent a lot of time on, when I could show you what I've actually been working on and what my priority is right now. A little bit more about Fusion. I thought I'd kind of show you for the folks that aren't super, engineers and into CAD that are watching. This is what I draw everything in, so it's made up of sketches, so I can roll back. This is the timeline, basically. You can roll it all the way back to your sketches. Basically, draw a rectangle, extrude it. I'm just going to kind of go through here. Another extrusion, give you some holes. Another extrusion, the countersunk hole. Another sketch, another extrusion gives you that pocket. And then we went through and got, the 4 little mounting holes. Went ahead and threaded them. Fillets around all the edges. Some more holes. Threaded that one. Another extrusion. Okay, now we're on to the second piece. And then I brought in the 2 bolts. Those are actually on McMaster car, so that's kind of cool. You can just go in and grab them. And located them. Yeah, I'm still struggling with that one. Thought I located them in the right place, but apparently when you rewind it, they move sometimes. I didn't actually constrain them because I need to figure out how to do that. I'm still new on this program. I had it nailed down in Inventor, and then my license expired, so Fusion's a little different. But the cool thing that I like about this is now you can go in from here to model. That's the model environment where you draw everything, and then you can go down to cam and you can start a setup. So you can define your stock and say what you're starting with, and then you can actually start going into all these different tool paths. And so that's kind of where I work from, and each one of these has a ton of different variables and settings to make it do exactly what you want to do. 2D versus 3D, these are more 3D contours as opposed to just flat shapes where you're drilling holes or cutting out pockets. Drilling, if you're lucky enough to have a 5-axis mill, you can do even cooler stuff. So that's kind of where I'm at. That's how I do things. I know I've gotten a few questions about how does this machine actually get its commands and that sort of thing. So from there, it's called post-processing, and it actually breaks it down line by line into machine movements. It tells those stepper motors, move this many steps in this direction this quickly, and you stream that code off the computer out in the garage. That's pretty much it for this week, honestly. Just a short little video. I didn't want to distract everybody on Christmas Eve, so I'm going to go ahead and put this one out a day early. So that's my Christmas present to you guys, I guess. Hopefully next week I will be machining this. I need to get some material, but I think it should be pretty easy to machine, knock on wood. And then try it out. I've sourced a vacuum pump that I can borrow, so at least that way I can make sure it works before I go spend money on a pump. So yeah, looking like about 2 feet of material. It shouldn't really cost a whole lot to make this thing, and I guess we'll go from there. So Merry Christmas, have a good one. See you next week.